My name is Michael Brett. I lead business development for quantum computing at AWS. I'm part of our high performance compute go-to-market team. And that gives you an indication right from the outset of how AWS thinks about quantum computing. Quantum computing is part of our high performance compute portfolio. So we offer a range of accelerated processing at AWS, from CPUs to GPUs to specialty processors. And now quantum computing is one more tool in that toolkit as an emerging technology that can assist with high performance compute workloads. Our approach to quantum computing at AWS is built on 3 pillars of activity, and I'll go through each of these in a little bit more detail. But first up is Amazon Braket. That's the name of our compute service from AWS. So Braket is a fully fledged compute service from AWS, just like any other form of compute. So just like our CPU and GPU offerings, Braket provides an accessible, pay-as-you-go, no upfront commitment access model to quantum computing. We've also got a team of professional services experts, scientists and engineers that can work directly with you to identify potential workloads for quantum computing, work through a collaborative R&D process, and then eventually, as the technology matures, bring that into production. And then we've also got the Amazon Center for Quantum Computing, which is our own deep R&D effort into quantum technologies. So a little bit more about that group. It's based in Pasadena, on campus at Caltech in California. We've built a purpose-built facility for quantum computing research on campus at Caltech. This is a fully AWS owned and operated facility. We share some faculty and resources with the university, but it's our effort to build quantum computing hardware, quantum computing algorithms and software, and help solve some of the problems that will help us bring this technology to commercial fruition as soon as possible. So what you see on the slide here are some of the first looks at AWS's own quantum computing hardware effort. We're in the process of building out prototypes for these systems right now. We'll be releasing more information about this hardware effort over time. But we're excited to be involved in the community that's building out quantum computing hardware at this time. So a little bit more about Braket itself. Braket is a fully managed service in the cloud, just like any other form of compute for AWS, to make it easy to explore quantum computing. And exploration really is the operative word here. It's an environment where you can design algorithms and applications, test out on high performance simulators on our classical infrastructure in the cloud, and then demonstrate the potential of those applications on quantum computing hardware today. So this is a high-level architecture diagram for Braket. There's a couple of key takeaways to take from this diagram. The first is that Braket is a part of AWS. So it's a fully integrated service, which means you can connect it into all of the other services of AWS. So you can build on top of Braket, build out solutions that incorporate storage and compute, and databases and robotics and machine learning, and all of the services that AWS offer can now be combined with a quantum computing service in the cloud that operates just like any other service in that environment. There's a number of different ways for users to access Braket through notebooks and a software development kit that you can run locally. We've got 3 different managed simulators that run in the cloud on classical infrastructure. So this is an extremely low cost and flexible way to work with quantum computing. And so customers and partners are building on top of these services. So Rebel Brown from QCI, just before us, they're one of our partners. So QCI have built out part of their application stack on top of AWS, and we're looking forward to working with other partners to build out their solutions as well. So today we connect into 4 different quantum computing hardware architectures. We launched Braket 18 months ago with 3. So quantum annealing with D-Wave, ion traps from IonQ, superconducting qubits with Rigetti, to offer customers a choice of hardware to explore for themselves. Just this week, in the last couple of days, we added a new hardware system from Oxford Quantum Circuits. It's the first UK-based, European-based hardware that's been added to a cloud service. It's the first regional expansion for Braket as well. We've added a quantum computing we've added Braket to one of our UK regions for AWS. which means that now UK and European-based customers can work within the Euro environment. So if they've got data sovereignty and GDPR requirements, they can access Braket there. In the next couple of months, we'll be adding a 5th computer to Braket from QEra. This is a Rydberg atom device from a Harvard University spin-off. This will be the first Rydberg atom-based quantum computer added to a cloud service. And it allows a particular type of quantum computing application called analog Hamiltonian simulation, which is good for chemical simulation approaches. So what you can see here, the key takeaway from this is that we're working with multiple hardware partners to provide a pathway to market for them to integrate into a globally distributed cloud service. And then our customers can access multiple different hardware systems and essentially with one line of code changed, target different hardware systems with different properties with their application stack. We'll be adding more hardware to this lineup over time, including AWS's own hardware. But AWS won't be exclusive on its own service either. We will continue to work with other hardware partners, just like we do in the classical compute side as well. So one quick example of customers that we're working with at AWS, we ran a program with BMW last year called the BMW Quantum Challenge, where we identified 4 candidate solution problem sets for quantum computing that could be tractable on today's platforms on Braket. And so with these 4 application areas, we defined the problem, we provided some sample and test data, and then opened up to the world to respond to these challenges and see if they could provide a viable solution to these potential problems for quantum computing. We ended up with 4 winners, one for each of the applications that we're investigating, which included Accenture, who's here today. So Carl, great to see you and your team here today. One of the winners of the BMW Quantum Challenge. And that group is, all of the groups are now engaged directly with BMW to continue developing those solutions and then hopefully eventually launching them into production with BMW as well. So pathways for you to engage. For our research customers, we've got a research credits program to offset any of the costs associated with exploring quantum computing from a research perspective. Our AWS partner network, companies like QCI and others, building on top of Braket, and we work with them through a partner relationship model where we can help you together achieve your outcomes. We've got hardware builders like Braket and IonQ and Oxford Quantum Circuits that are coming to Braket. So if you have hardware and are not yet in conversation with us about potentially adding to Braket, we'd love to have that conversation. And then, of course, enterprises can engage directly with the Amazon Quantum Solutions Lab, where we can work with you, potentially in partnership with one of our APN partners as well, to identify problems like what we did with BMW and bring those to the world. So a couple of links and resources, I'll drop these into the chat as well, but we look forward to the conversation with you.